Let's go over part number 1 of the review questions for this chapter on energy. So you should have already went through these things. We're going to start off with the questions. We'll come back to the terms because a lot of the terms we're going to define as we go through the questions, and then we'll come back and make sure we've hit them all. So the very first question says, list the 2 factors that influence the amount of kinetic energy an object has. So what are those 2 factors that influence kinetic energy? One is mass. The greater the mass, the greater the kinetic energy. The second one is velocity. The faster the object's going, then the greater the kinetic energy. All right. And remember we talked about the idea of roller coasters and that whole idea that if you can ride on a roller coaster with a lot more people, that gives you greater mass, which will give you greater kinetic energy, which means you'll be going faster. And then the faster you go, the greater the kinetic energy also. Second question, list the 2 factors that influence the amount of potential energy an object has. Well, there's 2 things. One is position. Position is how high you are. The higher the object is, because of gravity, the greater the potential energy. If I told you, okay, well, tomorrow we're all going to Cedar Point together, but the only thing we get to ride are the little bitty kiddie rides. You're probably be like, wow, that's not very exciting, right? Because that means you get to ride on the roller coasters that are like 10 feet tall. That's pretty boring. Most people are like, I want to ride a really tall roller coaster because the taller they are, then the more energy I got the potential to use. So that's one way is position, how tall something is. Taller it is, greater the potential energy. Second one is condition. And the way in which I like to describe this one is think of the battery that's in your phone. You get up in the morning, you pick up your phone, and you're like, oh, my battery is only half charged. It's not going to make it through the whole day. I don't have very much potential energy in my battery, and I'm going to have to charge it halfway through the day. So you're looking at the condition of the battery versus you wake up the next day and you're like, oh, sweet, it's got a full charge. I got a lot of potential energy. I won't have to charge my battery all day. I'll be able to use my phone all day. So the condition of that battery determines how much energy you have potential to use. So, all right, question number 3. Which object has more gravitational potential energy? So we're talking about potential energy due to gravity. So basically it has to do with that idea of height. So first one, we got a rock 10 meters up or the same rock 20 meters up. So which one's going to have more? The one that's 20 meters up. Higher it is, the greater the potential energy. Second question, now we're looking at something different, and that is the 100 kilogram rock or a 200 kilogram rock, both sitting on the same 10 meter ledge. So they're both sitting at the same height. Which one's got more potential energy? The one that's got more mass. All right, so that 200 kilogram rock does. All right, number 4, draw a pendulum swing and label the potential and kinetic energy and the changes that occur. So if we have a pendulum that's going to swing across like this. All right. So we're going to get point A, point B, point C, point D, point E. Sorry, that's background. That's the music going off for lunch. But so this point over here, this spot is going to have high potential energy. All right, so it's got lots of potential energy, and it's really got very low, kinetic energy. All right, it's not moving much, but it's got lots of potential to swing down. Down here, point C, this has got high kinetic energy. It's going to be the spot where it's going the fastest, and it's got very low potential energy. So what's happening at point B? Well, we're increasing kinetic energy and we're decreasing potential energy because it's starting to speed up. Now, as we come up on side E, what we're going to do is we're going to increase that potential energy and we're going to have low kinetic energy because it's going to slow down and stop. So what's happening at point D? Well, then we're losing kinetic energy and we're gaining potential energy as we start to go back up the other side. All right. So make sure that you're aware of that drawing. All right. Number 5. Why does a pendulum or swing stop swinging? So if we had this thing swinging back and forth, as we all know, it's going to go near. It's finally going to stop. Why did it stop? Because there's a law that says that energy can't be created nor destroyed. So I obviously didn't destroy it. Where did it go? Right in there. And it's all due to friction, and friction produces heat, right? Because I have heat, that heat goes floating off in the atmosphere, and I lose some of the energy due to heat. Didn't get destroyed, it just changed into heat, went floating away. So that's why it slows down and finally stops. Number 6, if you were to shake a cup of sand for 2 minutes, why would the temperature increase? So you sit there and you shake some sand inside of a cup, it's going to get and you measure the temperature after 2 minutes, you're going to find the sand temperature goes up. Why? Because they're rubbing against each other. And as they rub against each other, it increases friction. And friction gives me heat, and I get a higher temperature, more kinetic energy. The more I shake it, the more kinetic energy I give it, the higher the temperature goes, right? So that kinetic energy relates to temperature, which is coming up later. All right, number 7, describe how energy can be transformed within a car. All right, let me get rid of this diagram. We'll draw another one. So if I have my car, and I got gasoline sitting in the tank. Well, gasoline in the tank is chemical potential energy, right? It's a chemical, and it's got the potential energy to get you going down the road. Now, this all of a sudden, tells you got a half a tank. Oh, you know how far you can go. If you got a full tank, you can go even further. So it all has to do with that condition of the amount of gas you got in there. Now, as we burn that, we can turn this into 4 different things. One thing we can turn it into is mechanical kinetic energy, which is like the wheels going around. Right? We can turn it into radiant kinetic energy, which that's like the headlights. And the headlights coming on, that's radiant. We can also turn it into thermal kinetic energy, and that's heat. There's lots of heat. We lose lots of energy in our car to heat. And then finally, the last one is going to be electrical kinetic energy, and that's like running the radio in your car. So when you burn that chemical potential energy, the gasoline, these are the 4 things that turns into. Right? We didn't destroy it. All right, all we simply did was change that energy into something else. Okay. All right, number 8. If a student lifts a car that weighs 20 newtons from the floor to the tabletop, 1.5 meters high, how much work is done? Well, when we do that, did I miss one? Number 5. Oh, okay. Oh, it is. Also, look at my notes. All right. So on that one, what we got to do is we got to use work equals force times distance. Right? So we have a force of 20 newtons, a distance of 1.5 meters. If we multiply those out, then we're going to get an answer of the work equals 30 joules is the answer. All right, so 20 times 1.5 is 30. All right, number 9, what forces will slow down a person that is swinging on a swing? We kind of already talked about this, and this looks like I kind of doubled up my questions, and that is friction. Now, how can I reduce that friction? Some ideas I can do it. I can oil it. If I put a little bit of oil on it, it makes it slide better, and I have less friction, and therefore my swing will go longer. Right? Number 10, how does temperature relate to kinetic energy? As kinetic energy goes up, temperature goes up. Because remember the idea of shaking the little container of sand. If I lower kinetic energy, make them move less, then that lowers the temperature. All right. So, and that was the reason why we talked about there's no such thing as cold, because everything is moving. All right. So everything's got kinetic energy. If everything's got kinetic energy, then everything's got heat. There's only one time when there's no kinetic energy. That's absolute zero. We could really call that cold, and that's really, 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 really cold. It's like negative 400 and some degrees Fahrenheit. Really, really cold. All right. All right. Number 11. Heat always travels in what direction when you put an ice cube in your hand? So I put an ice cube on my hand. What direction is the heat going? The heat's going from my hand into the ice cube. All right. The kinetic energy of my hand is increasing, raising the kinetic energy of the ice cube molecules, making them go faster. That's why they start to melt, is because they go faster and they start to slide around on each other, and I end up with a wet hand. Okay? The reverse does not happen. That ice cube does not stay as a solid and make my hand into a solid. That does not happen. Okay? Instead, it's always the heat goes from hot to cold, or to an area where there's less kinetic energy. All right, number 12, this one's always really hard to follow. And that is, how does the specific heat of water, which remember we talked about specific heat of water is that how much energy it takes to raise the temperature of water, which takes a lot. How does the specific heat of water keep the temperature of land at a relatively constant temperature? So think of Los Angeles, California. Well, what's right next to LA, California? Big, humongous ocean full of water. Well, that big, humongous ocean of water does not like to change temperature very much. So it makes it so LA stays a constant temperature pretty much. It goes up a little bit and goes down a little bit, but not very much. It stays pretty constant. That's why people like to live there. I go to number 13, says the same idea, but now we're going to talk about Topeka, Kansas. Well, where's Topeka, Kansas? Right in the middle of the United States. Is there any water around it? Not much. It's mainly just dirt. And because there's dirt, when the sun shines down on it, temperature goes way up really fast, so it gets really, really hot in the summer. In the wintertime, it loses its heat really, really fast, so the temperature goes way down. So we get this really big fluctuation. Temperature goes way up and it goes way down. Unlike LA, because of that water next to it, the temperature stays relatively constant all the time and doesn't change very much. Another place that would happen would be like Florida. People like going to Florida because the temperature doesn't change very much. It stays pretty even all the time. All right. That concludes. Oh, now we're going to go back to the terms real quick. Potential energy, we already talked about that. Kinetic, thermal, electrical, radiant, nuclear energy. Now, there's no nuclear energy in the case of a car, thank goodness, otherwise we'd all die. Right? But nuclear energy is something you get from the tearing apart of atoms. All right. Law of conservation of energy, that says that energy can neither be created nor destroyed. All we're simply going to do is change its form. All right, we already talked about gravitational, we talked about chemical, we talked about pendulum. Period of a pendulum, that's just it swinging back and forth. Each time it swings back and forth, that's a period of a pendulum. Weightlessness. What's weightlessness? That's the idea of free falling. That one probably don't have to worry about. That's not going to be on the test. Periodic motion. That's the idea that motion swinging back and forth, like the idea of a swing. Energy, heat, temperature. We talked about all those specific heat. Conduction, convection, radiation. We talked about those way back when. So those won't be on this test. We talked about those in an earlier chapter. So that takes care of the that piece of it. That's part number 1. So now you can go to part number 2 in the next video and we'll talk about those. See you in a minute.